You know how models like ChatGPT just completely changed the game for AI and language? I mean, it felt like an overnight revolution. Well, get ready, because that exact same kind of revolution is happening right now, but for AI vision. Okay, let's dive into this.
So what if an AI could learn the fundamental laws of our world? Things like gravity, buoyancy, air resistance. Not from reading a single textbook, but just by watching things happen.
Or get this, what if it could reason its way through a brand new problem, like figuring out a maze by visually thinking its way to the solution, one step at a time? Now, this isn't some far-off sci-fi concept. According to some absolutely groundbreaking new research on video models, like Google's VO, these incredible abilities are emerging right now. This is the next giant leap. So that brings us to the big question. Is AI vision about to have its GPT-3 moment? Researchers are making a pretty bold claim that just like large language models became these general do-it-all tools for language, video models are on the exact same path to becoming the foundation for all of machine vision. To really get why this is such a huge deal, just look at this comparison. A few years back in natural language processing, or NLP, you had a different tool for every single job, one for translation, another for summarization, and so on. Then LLMs came along and could basically do it all. Well, machine vision today is in that same fragmented state, but that is all about to change. And the secret sauce behind this whole shift is something called zero-shot learning. This is the magic that lets a single, massive model tackle a brand new task it's never seen, based on nothing more than a simple prompt. No special training, no re-engineering, you just ask and it does it. It's kind of wild. And this quote from the researchers just illustrates the core argument perfectly. They say, in NLP, prompting replaced task-specific training. A similar paradigm shift is on the horizon in machine vision, facilitated by video models. So the key takeaway here is we're moving from a whole toolbox full of specialist tools to one single visual genius. All right, so let's break down how this actually works. It happens in stages, kind of like leveling up in a game. We'll start with the first two levels, simply seeing the world and then moving on to truly understanding it. So the first emergent skill is perception. And this is the model's ability to just see with incredible sophistication. It spontaneously learns how to do all these classic computer vision jobs without ever being specifically taught how. Now, what's really interesting are the examples here. Of course, it can do things like detect the edges of an object, or separate it from the background, and even sharpen a blurry image. But what's really mind-blowing is that it can pull off tasks that require this higher-level pattern recognition, like spotting the Dalmatian in that famous illusion, or even interpreting other complex optical illusions. Okay, so let's move to the next level and see how this builds. After perception comes modeling. Now the AI isn't just a passive observer anymore. It starts building an internal intuitive physics engine, basically a mental model of how things in the world are supposed to behave. And the examples here are just incredible. It understands buoyancy. It just knows a rock will sink while a plastic cap floats. It gets air resistance, simulating how things would fall differently on Earth versus the moon. It can even play visual Jenga, predicting which block you'd have to remove to make the whole tower collapse. It's developing actual common sense about the physical world. Okay, so the model can see and it can understand. What's the next logical step? Well, actively changing and manipulating the visual world it perceives. And this is where things get really, really creative. And this new ability is a direct result of those first two levels. Because it can perceive an object and model its physical properties, it can now manipulate it in a way that looks and feels completely realistic. So what can it do? Things like instantly removing a background, realistically changing the pose of the 3D character. It can even take a casual selfie and turn it into a professional headshot, completely adjusting the lighting and perspective. It can even simulate complex tasks, like a robot hand unscrewing the lid from a jar. This brings us to the final and, honestly, the most profound level of ability. The real aha moment of this entire research. This is where the model goes beyond just seeing or doing and starts to visually reason. Now, you've probably heard of chain of thought reasoning in language models, right? It's that process where an LLM talks itself through a problem, step by step, to get to a better answer. It's basically how they think using words. Well, researchers have now discovered the visual equivalent. They're calling it chain of frames. The video model uses the sequence of frames in a video to think through a visual problem. Each frame becomes a step in its reasoning process, which lets it solve problems that need planning across time and space.
And here's the key quote that just ties it all together beautifully. It's a direct parallel. Chain of thought is for reasoning with symbols and language. Chain of frames is for reasoning with the physical world across time and space. And here's the proof. Look at this chart on maze solving. The older model VO2 could only solve a simple 5x5 maze about 14% of the time. But the newer model VO3, using this chain of frames reasoning, solves it 78% of the time. That is a monumental leap in reasoning. It shows that as these models get bigger and better, this emergent skill just gets dramatically more powerful.
So what does all of this actually mean? Well, we're not just looking at a better way to generate videos. We are looking at a completely new foundation for machine vision itself.
The researchers conclude with this really powerful statement. That incredible jump in performance between the model versions isn't a fluke. They say it's a clear signal that video models are on an unstoppable path to becoming the unified, general-purpose foundation for how AI sees and interacts with our world.
And that leaves us with a final and pretty crucial question to think about. Once we have an AI that doesn't just see the world, but can actually reason about it, what are the possibilities? What's the most exciting application you can imagine? And maybe, what's the most concerning? Let us know what you think.